I don't really understand it. So many people making so much pollution, and then they're harming themselves. And poor little innocent creatures like me.
Thank you, Hamilton. So, as Hamilton was saying, more pollution, and this time air pollution. Some of it overlaps with what we did last lesson with water pollution. And in terms of keywords, so first of all on here we've got, I'll just use the highlighter again. In terms of new words, lots of you will have heard of acid rain, and one of the misconceptions a lot of people have with acid rain is that it will burn you and it's really strong, etc. Now, acid rain tends to be a weak acid, but over time that does have problems. So over time, slowly corroding away and affecting trees and leaves, over time building up in soil or waterways. So over time, acid rain causes serious damage, but it's not a matter of if you get caught in acidic rain that you're going to get burned. Incomplete combustion, we did combustion and burning and the release of carbon dioxide earlier. Sometimes you get incomplete combustion where there's not enough oxygen there, so you get particles of soot, and that links directly to, so you get little carbon particles formed, and those can be released into the air as well. And those particles of soot can build up on things, make buildings black, build up in chimneys. Chimney sweeps used to clean them out. Or those particles of soot caught in the air, if they build up with lots of particles of soot and smoke building up in the air, it's called a smog. So it's a type of fog, but obviously full of particles. And why it says here, it's very harmful to health. If you live in a big city without fresh air, and you're always breathing in particles of soot and small particles in the air, it can really affect your lungs. And those small particles are called particulate matter. So particulate matter are very fine particles in the air from exhaust fumes, from factories, from industry. And as you can see, all of these key words are sort of linked. It's that incomplete combustion leading to particles of soot in the air, or the buildup of soot elsewhere, and forming the smog as well. So they all sort of all go together, and hopefully during this lesson you'll have a full understanding of what they mean. Just a nice image here to start off with air pollution. So a power station releasing lots of smoke and water vapour into the air. Obviously inside there the carbon dioxide contributing to global warming, the water vapour contributing to global warming, and there may well be particles of smoke, etc. Now, different countries have different laws with how much pollution or smoke you can release and what standards you have to reach. But obviously, once it's in the air, it can affect people in a wide range of places, especially depending upon which way the wind's going and where that pollution is carried. So, in terms of air pollution here, I'll try and change pen again. So, easiest way to think about it, from this very, very well drawn car here, we've got particles, and from the factory here and from the power station here, all of them burning fuels and releasing carbon dioxide, which, as we know from previous lessons with the carbon cycle and deforestation, etc., that's one of the main gases contributing to global warming, and we looked at the impacts of that before. However, from a car with the really high temperatures in there, and from some industries and power stations, depending upon the fuel they're burning, especially if it's coal, there is a mixture of other gases. So if there's any sulfur in your coal or your fuel, it produces sulfur dioxide, and it can also produce a group of gases called nitrous oxides, which could be nitrogen oxide or nitrogen dioxide. These three are the ones that could potentially cause acid rain, and we'll come to that in a minute. And then again, from all three of those sources, so from the car, depending upon what type of exhaust you've got and filters on the exhaust, and also depending upon what fuel you burn, diesel cars are well known as being the worst, much worse than petrol, etc. up here we have these fine particles called particulate matter, PM, and they're measured in micrometers. So millimeters are a thousandth of a meter, and the micrometer a thousandth of a millimeter. So you're talking about particles. 1 micrometer is 1,000 times smaller than a millimeter. So very fine particles in the air of different sizes. So some of them get further than others into your lungs. So what we want to focus on here really is the acid rain pollution. We've already done the global warming and the particulate matter pollution. So in terms of acid rain, it's not rocket science. Well, it's acid rain science. So here we have our fuels being burnt, and if that smoke is not cleaned, if it's not filtered, etc., we can have sulfur dioxide and nitrogen oxides released. And what they do is, because they're very soluble, they can dissolve in the water vapour in the air. And as we learnt in the water cycle, those clouds could potentially travel anywhere depending upon the wind. And when it rains, that rain is slightly acidic. Now, over time, that can take the waxy surface off leaves. That can make the soil more acidic and therefore affect the way the plant grows. Some plants are very specific on what pH soil they like. That can get into rivers and lakes. So I'm just going to write water there because obviously it can affect creatures there. So if we could cut down on the emissions of sulfur dioxide and nitrogen oxides, if we had better fuels, more efficient engines, better filters on exhaust, if we filtered the smoke here coming out, if we reduced the burning of fossil fuels here, there would be less of these gases, therefore less acid rain, therefore less potential damage to the environment. And a lot of this depends upon where you live, because those can be blown anywhere, and there are typical weather patterns. Where we live in Portsmouth, basically, because the wind usually comes from the southwest, we get really clean air from over the Atlantic Ocean most of the time. So actually we get really clean air and really fresh rain. Whereas other places, if you have a lot of industry here and you live here, and that is polluted air, it could potentially cause acid rain damage here. So what I would suggest you do is pause, and your diagram might be slightly better than mine because I'm slightly artistically challenged, but if you pause here, I would suggest you do a little diagram for acid rain. For those of you, this is a more professionally produced, very similar version, but I would actually add your own descriptions on in your own words, and nice and colourful, memorable. Okay? Excellent. Hopefully you've done.
Me again. Well, the thing is, if the acid rain damages the trees, what will I eat?
It's bad enough with the sewage. Never mind acid in the water as well, from acid rain. Oh dear, whatever next?
Just a few questions. I'll let you try those 3 questions. Pause and do that. And then, if you could, have a look at what you've put. Did you cover those areas? Add anything else on now. Maybe highlight it because you didn't get it right first time. And anybody else got anything to say about acid rain? Oh, okay. Now, the other thing to mention at this point is when we did water pollution, we talked about indicator species, and depending upon how clean the water is, you get different animals living in it. And it's exactly the same with air pollution, and a good indicator species is lichen. Lichen is that most people don't see it as a plant, etc., but it's a type of plant. It feeds from sunlight, it gets the water vapor it needs from the air around it, and you get different types of lichen. And so here, for example, these bushy lichen and these bushy lichen here, these grow in areas where there's a really good air quality and very low pollution. However, if there's a bit of pollution, then you tend to get the leafy lichen, not the bushy ones. And then if there's a bit more pollution, so it's quite polluted now, you won't get your bushy lichen and you won't get your leafy ones, you get crusty lichen. So not growing far away from the surface of the tree or the rocks. What it means is that the areas are fairly polluted there. And then if there's lots of pollution, you'll get no lichen whatsoever. So again, pause and write down about how lichen can be used as an indicator of air pollution. And remember, it's number one, the bushy lichens are the ones that like really, really clean air. Number two, the leafy lichens are the ones that can tolerate a small amount of pollution. Number three, the crusty lichen are the ones that can tolerate more. Okay, now we talked about particles of soot and particles of smoke, especially from diesel engines and from industry if it's not filtered or removed. And just want to point out a few things here. It shows on the diagram here, if the particles are 10 micrometers, they can get into this area of your lungs. However, smaller particles can penetrate deeper, and smaller particles again can even get right down into the depths of your lungs. Wrong colour pen sort of thing to do this, so I'll try this one. So right down here in the depths of your lungs, and they can even pass over into your blood. So we've got problems here, respiratory, that's your lungs. We've got pulmonary, again that's your lungs, not working as well and over time. And there's a range of things here. If you suffer from asthma, it'll be a lot more severe, taking in lots of particle matter. If you can develop a disease called emphysema, where you lose loads of your lung surface area over time, and that takes years and years, but it may be that at the age of 40 you've only got the area left of one lung instead of two because of the amount of particle matter inhaled in a really polluted city. And then we've got infections like bronchitis, where you'd suffer from bronchitis and get lung infections much more often if you have all these particles coming in than somebody who lives in a clean place. Then we've got a series of things here. Dermatological diseases, they're skin diseases. So actually those particles on the skin all the time, irritating the eyes and skin, increasing the risk of lung cancer depending upon what the particles are and how they affect your lung cells. And then you've got here again increased risk of cancer and increased risk of heart attacks. So for particulate matter, those very fine particles of smoke, could you just pause and write down how they could affect our health? And exactly the same sort of idea, the very fine particles, just linking it back to biology 1, getting right down into the air sacs, into the alveoli, and potentially moving into your blood if they're small enough to, and they can diffuse across.
Hello, my name's Dylan. I get a terrible cough from all this dirty air sometimes. Really gets a chest infection, gets me down.
Which types of cars are we trying to reduce using? Number 5, what effect does smoke and particulate matter have on buildings? And number 6, what can help to reduce the amount of waste and pollution in the environment? And check your answers against these. And then a summary task at the end. Either number 1, task 1, produce a cartoon strip showing the production of acid rain and its effect on the environment. Now you might have already done a diagram on that, so maybe tasks 2 would suit you better. Complete the table, giving 3 causes for the type of pollution and with some examples, so it's a bit of a recap of the last few lessons. And task 3, research the actions that have been taken to maintain air quality. So what's in place at the moment to help us have good air quality? If you look at the Clean Air Act, for example, and that Paris Climate Agreement, what have a lot of countries now signed up to clean up our air over the coming years? Excellent. Thank you very much.